Hi guys and girls, I miss you all. I'm making a video for you today to review your answers to the lab sheet you did yesterday, which is Data About Us Investigation 1.1, where you had to count the length of names for everyone in your class and put that information in a frequency table and then make a line plot with it. And then do the same thing with the name lengths of data that I gave you for Chinese names. I want to talk to you today about the answers to that and how to compare that data. So we're going to take a look at both line plots and talk a little bit about some information like range, mode, and how the data looks on a graph. So I'm going to flip the camera around and start talking about that information with you. Okay. All right. So this is the lab sheet that I'm talking about. Investigation 1.1, how many letters are in a name. And you'll see that all of the answers have already been placed on your worksheet for you. And then the frequency table has already been filled out. And then the same thing for the Chinese names. We have how many letters are in the names, and then the frequency table has already been filled out for you. So I'm going to go to the next page here that asks about making a line plot. And I'm going to help guide you into making a line plot using the data from your class. It says length of US class names, but I used your class data, which is what I asked you to do when you made yours as well. So up at the top it says a line plot is a graph that shows organized data, values on a number line using X's, or sometimes other symbols are used. Sometimes they use dots. The X's are placed above the number to represent how often each value is represented. So in my previous video, this is where I put sticky notes on the wall and then removed those sticky notes and put an X instead of a sticky note, changing a bar graph into a line plot. It says here that a line plot made with dots is sometimes referred to as a dot plot. So you may see a line plot with X's. When it says other symbols, you might also see a line plot that uses pictures instead. That may be something that you've seen in elementary school. And then oftentimes you'll see line plots that are actually made with dots, which we call a dot plot. So for this investigation, part C is asking you to make two line plots. The first one with your class names and the second one with the data from the Chinese name lengths that were given to you. So I'm going to go ahead and show you how to take the data from your class names, and I'm going to look at the frequency table that was filled out and use that to create your line plot here. So I'm going to put the frequency table next to your line plot here. See if I can line some of this up next to each other with some camera tricks here. And if you can see on the bottom of the line plot, I did add a title. I wrote name length on the x-axis. We were missing an x-axis title, and that's very important. So we have a main title, length of US class names. We have an x-axis title, and we have a number line that's numbered from 4 all the way to 21. Now we're not sure right now how far that's going to need to be numbered, so I just gave us a list of numbers to work with. Okay, now over here looking at our frequency table, I need to figure out a good starting point. So if I look at the number of letters that I have in the names in my table, I don't have any number of letters that have 5. I don't have any that have 6. I do have a 7. And if I remember correctly, that's Mia. Mia has 7 letters in her name. So when I go over to my line plot, I'm not going to put anything above the 4 or the 5 or the 6 because there's nobody in our class that has that many letters in their name. When I get to the 7, I know I have somebody that has 7 letters in their name, Mia. So I'm going to put an X there, okay? Now I'm going to take a minute to tell you that that number 7 is very important there because that's our smallest piece of data. That is what's called our minimum value. So I'm going to write that down here. Because that's going to come up later in our conversation, okay? Mia is our minimum value. She has the shortest name in the class. If I look at 8 in my table, I have one person that has 8 letters in their name. I don't have anyone that has 9 letters in their name, so I'm going to leave this spot empty right here. And actually I'm going to write down that there's going to be a gap here because there isn't anybody that has 9 letters in their name. If I look at 10, I have 3 tally marks. 3 people have 10 letters in their name. So I'm going to make 3 X's. And I'm going to try to make sure that those X's are about the same size. Okay? Now, if I just pause for a moment with the creation of my line plot, I want to point out that using the frequency chart is very helpful because all my data is organized, and that was part of our definition of our frequency table, is taking all of the data and organizing it. If I did not have that and I was just looking at the names, I would have to do something like this. I would have to say, okay, this person has 21 letters in their name. I'd have to go over to 21, put an X. This person has 14 letters in their name. I'd have to go over to 14, put an X. This person has 10 letters in their name. I'd have to go over to 10, put an X. I might forget what one I already did. I might go back up to 14, put another X, and then my data is going to be incorrect. So if I forgot where I just was with my frequency table, I can go back and I can look at my line plot and I can say, okay, wait a minute. I stopped at 10. I don't have any 11s. Maybe the 11 is a gap. I'll look over at my frequency table and I'll say, nope, I just didn't do 11s yet. I should have 5 X's for 11. So I'm going to write 2, 3, 4, 5, and I'm going to try to keep them all about the same size so that my graph is a little bit more accurate here. And then I'm going to just continue to create the rest of my graph. So I'm going to move my camera over here and I'm going to use my data so that you can watch me create the rest of my graph here. So I left off with 12. I have 2 people that have 12 letters in their name. I have 5 that have 13, so that should line up with my 11s. I have 2 that have 14. I have 2 that have 15. I have 1 that has 16, 1 that has 17 letters in their name, 2 that have 18. I don't have any 19s or 20s, so there's another gap right here. And I have 1 person that has 21 letters in their name. 1 person. That would be Darian. Darian has a very long hyphenated last name, and that makes Darian our maximum value. Maximum meaning he has the longest piece of data or the largest piece of data. So I'm going to make a note of that there. Okay, now I'm going to compare this information with the information that I have with my Chinese name links, and I've already completed that graph for you so that you can take a look at the difference between the two line plots. So let me move my camera a little bit here for you so that you can see both of the line plots. I want you to take a look at the difference between where the data is located in both of these graphs. Okay, if you look at the data in our class, it looks like a lot of our data is spread out along the graph. We have a lot of our data here around 11 and 13. So if you have 11 letters in your name or 13 letters in your name, it looks like if we found the average, I wonder if the average number of letters is somewhere around there. If I take a look at the Chinese names down here, look at where all of that data falls, all between 4 and 9. And most of it is here around 6 or 7. That's a big difference. If I take a look here, their biggest piece of data is at 9, and 9 is way over here toward the beginning of our data where there's a gap. They don't have any data past 9, and look at where all of this data is on our graph compared to theirs. Okay? So you may have noticed I put some extra notes on their part of their line plot. That is on the next page of our investigation. So I'm going to kind of flip back and forth here for you with the next piece of our investigation. Okay? The next piece talks about distribution of data. And I kind of just covered that by just looking at the shapes of the graphs. It says the distribution of data describes the organized data set as a whole. It often describes the data, it often describes the shape of the data set. So for example, you might say, looking at the graph, that most of the data is on one side of the graph. Like looking back at the Chinese data, it looks like most of their data is on the left side of the graph. You might also say that most of the numbers are on the 11. Maybe the 11 has the highest amount of X's, or the 14. So maybe you would say that the distribution shows a mode of 14 because 14 has the most X's above it. So looking at part D is asking you to answer the questions below. And the very first one talks about the data distribution. Is it located to the right, to the left? Sometimes maybe it's right in the middle. This asks, where is most of the data located in the US graph? To the right or to the left? So we kind of talked about, just taking a look at this data, that most of the data is toward the middle of the graph. It's really stretched out from 7 all the way to 21, but most of it is right there in the middle around 11 and 13. So I'm going to write that most of it's right in the middle there. Some of you might have written that it was more toward the right because it stretches all the way to 21. Or maybe you just wrote that it stretches from 7 all the way to 21. Okay, that was a tough question because we haven't really talked a whole lot about that yet. Where's most of the data located in the Chinese graph? Again, we talked about most of that data being on the left-hand side of the graph. And when data is mainly on one side of the graph, we tend to say that the data is skewed. So I wrote that down for you. Skewed to the left, okay? Now, if this is a lot of information for you, just remember that investigation 1 is an introduction to data about us. So right now we're just taking a look at it, taking some notes, and we're just learning all of this information, and we'll revisit again throughout the rest of the book. Okay? The next part of your lab sheet talks about minimum and maximum values. Those were pointed out in the graph already in our line plot, and they're asking you to fill it out in a little table here. So I went ahead and I rewrote our minimum value would be 7 letters. That was Mia's name. Our maximum value would be 21 letters. That was Darian's name. For the Chinese, they have 2 people that have 4 letters in their name for their minimum. Yu, Y-U, and Li, L-E. And of course, the last names would total to make 4 letters. And then people that have 9 letters in their name on the list, Yanlin and Dewey, or Dewey. And I'm not sure if I'm pronouncing those correctly or not, so excuse me if those are incorrect. All right, now, why do we need to know minimum and maximum value? Well, one of the reasons that we need to know those is because that'll help us find range, which is the next part of our worksheet. The range is the difference between the minimum and the maximum values. So if you subtract the 2, if you subtract the minimum from the maximum, you will get the range. So I went ahead and I did that for us. If you take 21 minus 7, you'll get 14. So the US name length range is 14. That just means all the way from our minimum to our maximum piece of data, that's stretched between 14 pieces of data. And then what is the range from the Chinese name lengths? That would be all the way from 4 to 9, or stretched between those 5 pieces of data, okay? If that doesn't make sense, let's look at it this way. We go from 4 to 9. So 1, 2, 3, 4, 5 pieces of data, okay? All right. Now the next part talks about mode. Mode is the number that you see the most often or the most frequently in a set of data. For example, if you look at the data set that I gave you there, there's some 2s, 3s, there's a 4, there's a bunch of 5s, a 6, a couple 7s there, and it's telling us the mode is 5 because there are more 5s than anything else. So if I look back at our graph here, for the US name lengths, we want to look at which number has the most X's above it. So I'm looking and I'm seeing that the 11 and the 13 are pretty tall. They actually look like they're tied. I could count and double check. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I could also look back at my frequency table and I could see how many have the same number of tallies. And 13 has 5 and 11 has 5. So that tells me that I have 2 numbers that share the mode. I have 5 11s and I have 5 13s. Okay. And then the mode for the Chinese name lengths I already wrote down is 6. If I take a look at this, there are more 6s than any other number in my line plot. Okay, so that is a lot of information. Hopefully you were able to double check all of your work as we went over this. If you have any questions, please know that I'm here to help. You can email me. And again, all of this information will come up again in our next investigations. Just to let you know, on Monday, you will be filling out another lab sheet similar to this but we are going to compare name links from a different part of the world, maybe Japanese names or Korean names or Russian names. So be thinking about if you know anybody that has a name from one of those places, and we will do some comparing on Monday. Okay, until then, it was good to see you virtually, and hopefully I will see you sometime soon, maybe on a Google Meet or maybe in person. Until then, just remember that I love you and care about you very much, and stay safe. Okay, bye.